I'm going to go through how to draw some simple complex ions. In this first example we've got a chromium with 6 ammonia molecules as ligands. When the metal ion has 6 bonds to it, we'll always be drawing an octahedral, so that's a good place to start. So I'm going to put my chromium in the middle and then draw myself a nice octahedral around it. Now of course it's the nitrogen in the ammonia molecule which is going to coordinate to the chromium, so let's make sure that we've got our nitrogens like so. Now if you want, you could draw all the hydrogens out individually, so something like that is fine, but I'm going to just do it a little bit tidier, and rather than showing all the nitrogen hydrogen bonds, I'm just going to put mine down as NH3s. Now that's easy on these on the right hand side. Just be careful with the ones on the left hand side. Don't draw them like that, so that's no good. Instead we just put them as H3Ns, recognising that it's the nitrogen that's bonded to the chromium. You'll also see cases where we can include the lone pairs. This is absolutely fine if you want to go around and put the lone pairs on. Perhaps not a bad idea in your exam, and if you see cases where arrows have been drawn on, then that's just indicating that it's a coordinate bond. The final thing is for us to recognise that this is a complex ion, so we'll draw our square brackets around the whole thing and then just pop the charge top right corner. So the shape was octahedral, which has a bond angle of 90 degrees. The coordination number is 6. The ligand is ammonia times 6, and the central metal ion being a chromium 3+. We can work this out because ammonia is a neutral ligand, so has no charge, so that 3+ charge must come from the chromium. In this next example we're swapping the ligand to a chloride ion, and these usually have a coordination number of 4 and tend to be tetrahedral. So why the change in shape and coordination number? Well, this is simply due to the fact that chloride ions are considerably larger than water molecules or ammonia molecules, and we can't get as many around the metal ion. That being said, let's draw this complex. So it's tetrahedral. We'll start by drawing the copper at the centre of it, and a tetrahedral around the copper, like so. And our ligands are chloride ions. You might be wondering why I've not put a minus charge on each of the chlorides. Well, that charge is taken in with the whole charge on the complex ion, so that's what we've got so far. Nothing else to do here, and then we have the charge on the outside. So this time the shape is tetrahedral with a bond angle of 109.5. The coordination number is 4. The ligands are chloride ions. The central metal ion is clearly a copper, so what's the charge on the copper? Well, we've got 4 chlorides, each with a charge of -1, so that's -4, and the overall charge on the complex is -2, which means the charge on our copper ion must be +2. The next example is very simple. We won't see lots of these. This is with a coordination number of 2, and this renders it a linear complex. This example is the one that we'll see most of, and it's the silver complex present in toluenes. So to draw this, nice and easy, just give ourselves a silver, and for it to be linear, something like that, and we need 2 ammonias, Remember, bonding through the nitrogen, which has the lone pair. Let's pop the lone pair on in this example. That's pretty much it. The charge on this complex is +1. So we have a linear complex with a bond angle of 180. The coordination number was 2. The ligand was ammonia, and the central metal ion is silver. And remember, the ammonia molecules have no charge, so this +1 charge must be coming from the silver. This final example is another one with a coordination number of 4, but this time it has a square planar shape. You'll see at the bottom there, so nickel, platinum, palladium will often follow a square planar shape, and the complex that we're looking at is one that you will see in the DNA pack, so it's the anti-cancer drug cisplatin. Now, it's perfectly fine to draw a square planar like this, but I prefer to draw it the other way, by which we'll draw our platinum there and then our 4 bonds coming into the platinum like so. So there's our square planar shape. Now, in this complex you can see we have 2 ammonias and 2 chlorides as our ligands. If we just put them randomly on the molecule, let's have a look at this. What you can probably see is that my chlorides are now across from each other, so I've drawn the trans isomer here. So to rectify, what I need to do is swap the position of those 2 ligands. Now I've got the chlorides adjacent to each other, or indeed the ammonias adjacent to each other. So this is the cis isomer. So that's our complex done. You can probably see that there is no charge in the top right hand corner, so this complex carries a charge of 0. So this is square planar with a bond angle of 90, a coordination number of 4. In terms of ligands, we have 2 ammonias and 2 chloride ions. The central metal is platinum. For the complex to have a charge of 0, now the chlorides are contributing a charge of -1, and we have 2 of those. The ammonias are contributing no charge, which means the charge on the platinum must be 2+ to make the overall charge 0.